So we were here, will the cart move? Yes, it will move. Why will it move? Because my horizontal component is greater than my frictional force. So yes, the cart will move. Okay. We'll just now move on to question number 7. Question number 7, also an interesting question. We now have a 12 kg block. So let's put a picture. You've got the 12 kg block and it's on a slope. So there's my 12 kg block. It's on a slope and it's at an angle of 30 degrees. Okay, now this question is easy because we're just working out components. So remember, when an object is on the slope, we have the weight acting straight downwards. We have two components, a parallel component, FG parallel. We have a perpendicular component, which we call FG perpendicular. And our normal force is what the surface exerts onto the object. So that there is my normal force. So the first question is, you need to calculate the weight component that is perpendicular to the surface. So FG perpendicular, or weight perpendicular, remember, has a formula. The formula is W cos theta, which is W cos 30 in this case. We work out our W times 9,8 multiplied by cos 30, and that gives us 102 newtons perpendicular to the slope. Okay, we're just plugging and playing with formulae here. Then B says calculate the component parallel. So W parallel will be equal to W sine theta, sine 30. So it's 12 times 9,8 sine 30. Sine 30 degrees is equal to 59 newtons down the slope. Okay, and C, you need to state the magnitude of the reaction force of the weight on the crate. Okay, so remember, it's the same two objects. So the reaction force of the weight, the reaction force of the weight of the crate. The reaction force will be the crate on the object, which will equal to the perpendicular component, which is equal to 102 newtons. Okay, the coefficient of static friction 0,25. Calculate the maximum static frictional force. So if we're working out the maximum static frictional force, it's going to be mu times n, which is 0,25 multiplied by 102, because that's what my normal force is, and I get 25,5 newtons up the slope. Up the slope. Okay, and will the box accelerate? So the box will accelerate if the parallel component of the weight is greater than the maximum frictional force. Okay, so if we look at this scenario, your W parallel is 59 newtons. Your frictional force is 25,5 newtons. So we can say, yes, the block will accelerate. Okay, in the next session, I will be marking number 8, and we'll see how far we go from number 8. Thank you, grade 11s.